Good evening, children. I hope everyone are doing fine. Let us continue with the chapter 5, that is periodic classification of elements. So today I am going to cover about the topics limitations of Mendeleev's classification and making order out of chaos, that is the modern periodic table. So let us begin. So children, in the classification by Mendeleev, so there are few demerits as well as merits. Okay, so first we shall learn about merits of Mendeleev's periodic table. So what was the merits? That he already predicted that some elements were not discovered, so which is going to be discovered in future, and he left the blank in the table what he has discovered, right? So that is, he named that blank space as Eka boron, as scandium. So that was later discovered. So he was just named Eka boron and left the space, right? So that left out space, he named an element that as scandium. So it was later discovered. Okay. Next, he left the blank, that is Eka aluminium. So later the element was discovered was gallium, that is Ga. And Eka silicon, where he named in a blank space, it was later discovered the element was germanium. Okay, sorry, M is missing. So it is germanium. So it is its a symbol is Ge. Okay, so the second merit of this Mendeleev's periodic table was the properties of many elements were predicted on the basis of their position in the periodic table. So where exactly the elements were placed, their position. So this position actually determines the properties of elements in the periodic table. Okay, for example, you can see in the table, so property Eka aluminium and gallium. Okay, so what is the atomic mass? That is 68. So which is slightly increased in case of gallium, that is 69. So here you can see increasing atomic mass. Okay, and formula of oxides, when it is combining with the oxygen, it forms E2O3. Okay, that is oxides, that is gallium oxide. And formula of chloride, so when it is combining with the chlorine, it forms gallium chloride. So this is the formation. So here the position of the element determines the properties as well. Okay. So the table could accommodate noble gases when they were discovered. So when noble gases were discovered, it accommodated its own space. Okay. By the way, what are the demerits? Now we shall discuss about the demerits, that is limitations. So the position of isotope could not be explained. So what do you mean by isotope, children? You have studied in 9th standard. It is same atomic number but different mass number, isn't it? For example, chlorine. So chlorine, we have same atomic number but different mass number, that is chlorine 35 as well as chlorine 37 we have. But what did Mendeleev do? He only placed chlorine 35. So what about chlorine 37? He didn't place that, right? So isotopes could not be explained by Mendeleev. The position of isotopes couldn't explained by Mendeleev. So he had placed only chlorine 35 and he left out chlorine 37. Okay, this was one of the limitations. And a correct position could not be assigned for hydrogen. Okay, so hydrogen stands in the very first place, right? So here hydrogen acts as metal as well as halogen. But hydrogen was not given, it was not assigned with a proper position. That was one of the demerits by Mendeleev's classification of elements. Next is wrong order of atomic masses of some elements could not be explained, that is cobalt and nickel. One among you were asked this doubt, right, in the previous class, I think Nitya. So Nitya, here is a proper explanation for your doubt. So what Mendeleev couldn't work on was, so he gave a wrong order of atomic masses of some elements, that is cobalt and nickel. So according to him, the arrangement should be in the increasing order of atomic masses, right? but cobalt and nickel were placed wrong, right? So you might have observed in the Mendeleev classification. Okay, so cobalt was placed first and next was nickel, but cobalt's atomic mass was 58.93, whereas nickel was 58.71. So nickel has to come first, right? But this was not arranged properly, so it was placed incorrect. So the wrong order of atomic masses of some elements could not be explained, that is cobalt and nickel. So that was the concept about merits and demerits of Mendeleev's periodic classification of elements. Next comes Henry Moseley, the year 1913. Okay, so according to him, he was a person who classified the elements in the periodic table that is now we are following, that is modern periodic table. According to him, the fundamental property of an element is not an atomic mass but an atomic number. He says that, so according to Daubernier, Newlands, Mendel, so the arrangements of element was based on the atomic mass, increasing order of atomic mass. But Henry says that it is not the atomic mass, but it is atomic number. So whenever you see chemical reaction, the transfer of electrons matter a lot, right? Isn't it? So here atomic number plays an important role in the elements during chemical reaction, because atomic number is nothing but number of protons or number of electrons. Here the outermost shell, that is electrons in the outermost shell, matters a lot in the chemical reaction. So there is a transfer of electrons, gaining of electrons, okay, giving out of electrons, isn't it? So according to him, it was a concept that it is not that atomic mass property is involved, but atomic number. Okay, so this table, hope you remember, it was given by Mendeleev, right? So here you can notice, children, hydrogen is placed in the first part, okay, first column. That is, here hydrogen acts as a metal as well as halogen, but he failed to give a special place for hydrogen. That was one of the demerits. And next was cobalt and nickel. Okay, so nickel has to come first, wherein cobalt should stand next to nickel, but he failed to give a order for cobalt and nickel as well. And next is isotope chlorine. So here you can see he has given only for the 35. Chlorine 35 he has given. What about chlorine 37? He failed to give that position also, isn't it? So this was the demerits. Coming to modern periodic law. So what does modern periodic law states? The properties of elements are the periodic functions of their atomic numbers. According to Henry, it is that atomic numbers matters in case of elements in the periodic table. Okay, so this modern periodic table consists of 7 rows and 18 columns. It is said to be long form of periodic table, wherein Mendeleev's periodic table was short form of periodic table. Okay, so I'll show you the modern periodic table. Okay, so you remember these points and we will relate these points to the modern periodic table. So what does third point says is group from 1 to 13, 14, 15, 16, 17. So remember, children, group 1, 2, 13, 14, 15, 16, 17 are called as normal elements. Okay, so last shell is incomplete with octave or duplet state. Okay, so last shell of this group is incomplete. Why? Because they fail to attain octave stage or duplet stage. Hope you understand. So K, L, M, N shells. Okay, if you remember atoms, you may recall it. Okay, K has a capacity of 2 and 4, 8, like that, right? So, but it fails to attain octave stage or duplet stage. Okay, so this last shell is incomplete, we call it as. Next is group 18. Whatever the elements is there in the group 18 are called as inert gases. And last shell of these group 18 is complete. That means they have attained octave stage as well as duplet stage. And what about group 3 to 12? 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are said to be transition elements. That is, Last two shell is incomplete. That means it has failed to attain octave or duplet state. And last two rows that you see, they are said to be inner transition elements, and their last three shells is incomplete. Okay, so here you can see the modern periodic table and you can relate to those points, isn't it? Yes. So here in this in your syllabus you are going to learn only about first 20 elements. Only simple elements you are going to study, not overall elements that you're going to study, not all 118 elements that you are going to study. The most important is first 20 elements. And I've already gave practice for you people to learn 1 to 20 elements. So one easy way to remember this 1 to 20 elements is, so on the top you can see there is one way to remember this is, hi, he lies because boys cannot open fishnet. Okay, so H for hydrogen, He for helium, okay, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, first 10 you can remember with this line. Next 10 is, Naughty Mowgli always sings pop songs claimed by AR, K and CA. Okay, so this is the way to remember other 10 elements, that is sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, potassium and calcium. Okay. So now you can see this modern periodic table. So here Henry has fulfilled all the demerits that was given by Mendeleev. Like you can see hydrogen has given a special place. It is not said that, he has not mentioned that hydrogen is not considered to be metal or halogen. Okay, it has given us a special place and it is out of other blocks. You can see in page number 86, it is separate from other groups. Okay, next is lanthanum and actinium. Okay, so here you can see the other elements which is being placed next to them. Okay, so next to barium and radium you can see these two elements has been placed. And chlorine isotope, so he has given chlorine, he has considered both, because according to him it is atomic number, right? Atomic number of chlorine is same, that is 17. So he has placed chlorine in the same position, that is 17. Okay, according to the definition of isotopes, what is the definition? Same atomic number but different mass number. Atomic number of chlorine is same, right? 17, but mass number is 35 and 37. So since according to him he has considered atomic number, he has placed chlorine in the same position, that is 17. Okay, you can see that. And cobalt and nickel, according to him atomic number is a priority, right? So what is the atomic number of cobalt? 27. What is the atomic number of nickel? It is 28. So he has placed in a correct position, isn't it? So this is about the modern periodic table, and this have all the merits, and he had covered all the demerits given by the Mendel. Okay, so this is the overall periodic table and elements that this is how the elements has been arranged. Okay, so I hope you have understood merits and demerits of Mendeleev's periodic table, as well as you have got a clear concept about modern periodic table. In next class we shall continue with the more topics of this. Okay, see you all children, have a good day.